Good afternoon, everybody, or good morning, depending on what part of the country you're listening in from. My name is Katie Flower, and I will be your lead instructor for today's Assabloi virtual instructor-led training course on positive pressure fire doors. We will be basing this on IBC, the International Building Code 2015 edition, as well as Nfpa 80. Within 24 hours of this class, you will receive a thank you email, which you can use for continuing education credit as your proof of attendance for 1 hour of credit. Also, this session is being recorded and will be on the Assabloi Academy website, where you registered for virtual instructor-led training. On the top right-hand portion of the website is a link to previously recorded sessions. So if you need to review anything more than once, you are certainly welcome to watch the recording. Or if you have a colleague that happened to miss this and you want to share it with them, then they can have access to it there as well. If you have any questions today, feel free to use the Q&A button on your Zoom control panel. Type in your question. I'll be monitoring that throughout the presentation. I'll also save some time at the end if you have any questions at that point. We have a lot to cover. Let's get into it. As I mentioned, we will be talking about the 2015 edition of the IBC. If your project is using a different edition, the information may be slightly different, but it's going to be found in a similar section. And you will first learn about the different wall types and levels of fire resistance rating, depending on what area of the building the wall is protecting or separating. And then we will get into finding the requirements for fire door assembly in terms of fire protection rating, and possible exceptions based on occupancy type. And then we will also find where the reference is to Nfpa 80. Nfpa 80 is the standard for fire doors and hardware. It won't tell you where you need a fire door, but it will say if you need a fire door, it needs to look like this and act like this and have this type of hardware. The code itself is what tells you what rating, what protection level that you need. So they work hand in hand with each other. And by virtue of that reference, the standard becomes part of the code. We'll talk about the difference between the positive pressure fire test versus neutral pressure, what the differences are, and how that affects the door requirements. And then finally, at the end, we will have a review quiz with some polling questions so that you can make sure that it's clear to you what those requirements are. So if you need to take notes, please feel free to take notes, and we can discuss any of those review questions at the end as well. It's very important to understand the differences between firewalls, fire barriers, and fire partitions. The definition of a firewall, they're used to divide a structure into two separate buildings. The division must be vertical, and it's going to go completely through the roof. The requirements for a firewall are much more restrictive than those for fire partitions and fire barriers. And because of this, the opening protectives in a firewall are also more restrictive than those found in other wall types. A firewall has to be constructed so that it will remain in place if the construction on either side collapses or burns down. And they're very rare, but you will find them from time to time in your projects. Fire barriers are much more common. They're used to compartmentalize large spaces into smaller fire areas to help restrict the spread of fire and smoke, thereby creating a horizontal exit. They're also used for enclosures such as vertical stairways, exit passageways, exit ramps, and other similar separations. For the most part, when you hear fire barrier, you should think of an exit. That is most common what it protects. But they are used to separate areas in a building that may contain more flammable materials than usual, like storage rooms, laundry rooms, and similar type spaces, in order to contain the fire within the room. A fire partition is a wall assembly that's used to separate adjacent tenant spaces in covered and open mall buildings, to separate dwelling units, to separate sleeping rooms, and to enclose corridors and elevator lobbies. The opening protective requirements in fire partitions are usually less restrictive than those for fire barriers. This table comes from Nfpa 80, and for new and existing fire doors, they're classified by one of the following designation systems, either an hourly rating, an alphabetical letter, or a combination of both. And you will need to find these requirements for fire door assemblies in the IBC or your local building code. B-label doors can either be 1 hour or 1.5 hour, 90-minute, depending on how many stories high the building is. A couple more definitions. A fire resistance rating is developed using standardized test methods like ASTM E119, Nfpa 251, or UL 263. And it applies to building elements such as walls, floors, and ceilings. There is a level of thermal property in a fire resistance rating. The assemblies rated under these tests are deemed able to perform their function for a specified period of time under specific fire conditions. If you exceed a side light or bar light of a certain size and percentage, or over 45-minute, for example, a 60-minute side light frame, then those they have to fall under the ASTM E119, and Seco and Curry's both have offerings that include the glass. It's a special thermal property glass, and there's a completely different Assabloi Academy course just based on that. But for doors, those have a fire protection rating, doors and borrowed lights. And opening protectives is just a fancy way to say fire door assembly. The ratings are stated in hours or minutes, and they can be combined with a letter designation indicating the portion of the building the fire door assembly protects. The standardized test methods include Nfpa 252 and UL 10C. When you see those in a specification, those will refer to the exact test. And a fire door test from IBC 2003 on has been the positive pressure test, which is UL 10C. Nfpa 252 just all by itself does not give you enough information if it's just specified Nfpa 252. The architect needs to also include where that neutral pressure plane is located. If they say 40 inches above the sill, then you know that's the positive pressure fire test. Let me talk about the difference between the two tests. They put the door assembly in the frame, in the wall, and then they clamp it to the furnace. They start the gas, they start the flame, and within the first 5 minutes, the temperature gets to 1,000 degrees. Now, in the old test, the UL 10B neutral pressure test, they would ventilate the hot smoke and the gas out of the top of the furnace, so it would keep the positive pressure plane right at the top of the door assembly. But that's not what happens in real life. So that test is IBC 2000 and earlier. That's what all doors in the United States were tested to. What that did was it would pull cool air in underneath the door as well as at the top of the door. But what happens in a fire, there is no chimney that ventilates the smoke and the fire out of the top. If you've got a room, the fire and the smoke will rise, hit the ceiling, and then start to come back down, pushing that neutral pressure plane to about 40 inches above the sill. That's called the line of thermal discontinuity. And you can see it. If you look at pictures of a building that has been subjected to a fire, the walls are really black and spackled above that 40-inch line and fairly clean below. And in fact, when you're younger, you're taught to drop down to the ground and crawl out because that's the area that's easiest to breathe. Smoke rises, the heat rises, and that neutral pressure plane ends up being stable right about 40 inches above the sill. And so on a real life fire door test, the UL 10C positive pressure test, now you're pulling in cool air underneath the door and pushing the hot air and the hot gases and possibly even flames out of the top of the door. And that's why we need to seal the doors a little bit differently when we test under positive pressure. A couple more definitions. We have smoke barriers and smoke partitions. A smoke barrier is used as a component to form smoke compartments in buildings. In healthcare occupancies, like nursing homes and hospitals, smoke compartments can be used to relocate people safely and promptly during a fire. The walls, floors, and ceilings would be continuous and would have a fire resistance rating as shown in the image. So a smoke barrier does protect against fire and smoke, whereas a smoke partition does not carry any fire resistance rating at all. It's intended to provide less protection than a smoke barrier. It's not required to be continuous through concealed spaces through the ceiling. The use of smoke partitions is limited and are most commonly used in institutional healthcare occupancies like those hospitals and nursing homes for the corridor walls that are not required a fire protection rating, but they do need to limit the transfer of smoke. So the main use would be on-call rooms, sleeping rooms, and patient bedrooms for the most part. When used all together, firewalls, fire barriers, fire partitions, smoke barriers, and smoke partitions, and their opening protectives provide passive separation and compartmentation in a building. These components are critical in maintaining means of egress continuity to allow building occupants time to safely evacuate or await help in an area of refuge. When I was a distributor, I used to like to draw different colors for my different fire barriers and fire partitions and smoke walls so that I could see the continuity and make sure that the architect had the doors marked on the door schedule correctly. And then I would have it in my head where that protection is, and if there is any lacking, I could ask the question. Then we need to go to the code. The IBC in Chapter 7 is all about fire doors, and 716 is the chapter on opening protectives. There are tables, and table 716.5 shows us the fire protection rating for doors in walls. So for firewalls, they're either going to be a 4-hour or a 3-hour rated assembly, and the minimum fire door will be a 3-hour A-label door. Then we continue down to the next part, and then they're saying firewalls and fire barriers having a fire resistance rating greater than 1 hour. If it's a 2-hour wall, it'll have a 90-minute or hour-and-a-half rated door. It also tells you the maximum size of glass and other things that you can use for that. Interior exit stairways that are 2-hour fire barriers will have 90-minute doors. And for the most part, when you have a building that's 3 stories or less, your vertical exit enclosures, 3 stories or less, will be 1 hour rated with 1 hour door. And if it's a 2-hour rated, it's going to be 4 stories and higher. So high-rise buildings, your exit enclosure is 2 hours with a 90-minute door. Because it's going to take longer, once you reach the exit, you're safe from the fire and the smoke, but it's going to take you a little while to get out of the building to the public way and safety. You're safer than you were because you're in the exit, but you're not completely out of the building. So the taller the building, the more the protection. And here is the fire barriers that are 1 hour resistant rated will have 1 hour doors. Then there are other fire barriers where you have a 1 hour wall and a 3/4 hour or 45-minute C-label door. And those you can find on the incidental use area table 509. And these are the types of rooms like your storage rooms, your laundry rooms, incinerator rooms, and things like that. And some of them are based on the occupancy type, but it will tell you your separation and or protection rating. And if you look to the right-hand side, not all of them require, some of them are 1 hour with no exception. Others are, you can either provide 1 hour fire barriers or fire partitions, or provide an automatic sprinkler system. That way the owner has a little bit of say in which way they would rather go. So if they go with an automatic sprinkler system in the I2 waste and linen collection, then it's one or the other. And sometimes it's both. It'll say and. So 1 hour and automatic sprinkler, because it's I2 laboratories, which is your hospitals, nursing homes that are not classified as high hazard. In that case, it's provide both. And then we have fire partitions and smoke barriers. They're very similar. A 1 hour fire partition for your corridor walls, your exit access corridors, your smoke barriers that are 1 hour will have a 20-minute rated door assembly. And those need to be tested the same fire test, but in America, in the United States, they do not need to pass the hose stream test. And then other fire partitions, a 1 hour wall would be a 45-minute rated door, and a half-hour wall would be a 20-minute door. And those are pretty rare, but you will find them from time to time. And here is the reference for NFPA 80. When the IBC references the standard, all of the requirements of that standard shall apply. So your fire door assembly, including the door, the frame, and the hardware, need to meet the requirements of NFPA 80, the standard for fire doors and hardware. Also in IBC 716.5.1 tells us that side hinged or pivoted swinging doors, which is what we deal with the most, swinging doors need to be tested in accordance with NFPA 252 or UL 10C. And here's where the architect needs to, if they're referencing NFPA 252 test, they need to say that after 5 minutes into the test, the neutral pressure level in the furnace shall be established at 40 inches or less above the sill. That's your clue that these doors are tested to positive pressure. If they say UL 10C, that automatically tells you that it's tested under positive pressure. There are other types of fire door assemblies in buildings. For example, sliding doors or other types of elevator doors and such. And those can be tested with the neutral pressure test. They don't need to be tested under positive pressure. But our swinging doors that we deal with on a daily basis, if it's IBC project, which is in every one of the 50 states, it needs to be tested under positive pressure. Smoke and draft control can get very confusing because, again, you need to know what's the difference between a smoke barrier and a smoke partition. So door assemblies in corridors, which will either be a fire partition or a smoke barrier, will have a 20-minute rated door that does not need to pass the hose stream test. And then it goes on to say that smoke and draft control is required as tested in accordance with UL 1784. Louvers are prohibited because these doors are in your means of egress. It's an exit access corridor that leads you to an exit. So we don't want that exit access corridor filling up with smoke and making the corridor untenable for egress. We want people to be able to reach an exit safely. And they need to be installed in accordance with NFPA 105. 105 is a standard. NFPA 105 is a standard. And by virtue of the reference, it becomes part of the code. So all smoke doors, whether they're fire rated or not, smoke doors and 20-minute doors need to be self-closing or automatic closing in accordance with NFPA 80. It also says that door bottoms are not required on smoke doors unless the door is part of a pressurization system. And that's because when you have smoke seal around the perimeter of the door, you have a 3/4 inch maximum undercut at the bottom of the door. The smoke rises, so you don't get a lot of smoke out of the bottom of the door. And if you seal that completely, it creates a vacuum and it makes it really hard for the door to close and latch, which is more important than sealing the bottom of the door. The sealing of the bottom of the door is just where you have pressurization. Louvers are prohibited unless otherwise tested, and the doors need to be labeled. If the door has fire exit hardware, the label is proof to the AHJ, the authority having jurisdiction, that the door is reinforced for the fire exit hardware, which is an exit device, and it's been tested for egress panic load requirements. Your frame requirements, only labeled fire door frame shall be used. The frame takes on the rating of the door. There is no actual hourly rating on the frame, unless it's a special like a side light or transom frame, and then we'll probably give the maximum rating that you can achieve. And the methods of anchoring are shown in the listing. The clearances around a fire door, the maximum top and vertical edges are 1/8 of an inch, including the meeting edges. That's plus or minus 1/16 of an inch on hollow metal doors because of the manufacturing process, and they bend the steel and bevel the edge of the door in most cases, at least the leading edge of the door. There needs to be a little bit of tolerance. Wood doors are machined, they can be exactly 1/8 of an inch, and metal doors expand when they're heated, wood does not expand. The clearances are measured on the pull face of the door. Now let's talk about the different categories for positive pressure fire doors. And I want you to please don't get confused, because the categories, the letters, have nothing to do with the fire rating of the door itself. So category A does not mean that it's an A label fire door. The label on the door and the category of the door are two completely different things. Please try to keep them separate. A category A door has no additional edge sealing system. It does not apply to hollow metal doors because a metal door does not need an intumescent seal in order to protect the opening. In order to pass the positive pressure fire test, when it gets to 1,000 degrees, that metal expands and there's not enough room for the hot smoke and gases and flames to get through. But it does apply to wood doors, 45-minute rated, 60-minute rated, and 90-minute rated. And because it's category A, that means that it has a built-in edge intumescent. Intumescent is a type of seal that will expand when it's heated. If you think of a marshmallow and you put it on the end of your stick and you hold it over the fire, you see that marshmallow gets hot and it starts to puff out and expand. That's what intumescent will do. It will puff and expand and fill the gap between the door and the frame. And category A has it concealed underneath the stile and rail of your door so that it's a much more beautiful looking edge treatment. It doesn't apply to 20-minute doors because 20-minute doors that have an S label for smoke need a category H smoke and draft control, and I'll show you the difference in just a minute. A category B positive pressure door does not have a concealed intumescent, and therefore you need additional edge sealing system. It can be applied to the door or it can be applied to the frame, but it's an intumescent edge sealing and it's a category G edge sealing system. So once again, this does not apply to hollow metal doors because they naturally expand when heated. It does not apply to 20-minute wood doors that have an S label. They need category H smoke and draft control. But what it does apply to is 45-minute, 60-minute, and 90-minute wood doors that do not have a concealed intumescent. Most architects prefer to use and specify a concealed intumescent, but this Pemco HSS 2000, it's 3/64 thick, has an adhesive backing. You can apply it to the door or the frame as an edge sealing system, but it's not that pretty. So wood doors by nature are specified typically because you want a warmer look. And as I mentioned, most architects will specify concealed category A, but you need to understand that if you see in a specification category B fire door for positive pressure, you better see in the hardware set some kind of edge sealing like the PEMCO HSS 2000. Smoke and draft control doors require a category H smoke and draft control gasketing, and that's like the PEMCO S88. It's an adhesive back fire smoke gasketing that's applied to the frame. This is used to comply with NFPA 105 for smoke and draft control. And where it applies is for 20-minute doors and S-label doors. And that doesn't matter if they're wood or metal. Smoke seal is used for the early stages of the fire for the cool smoke. So maybe the door, it protects your exit access corridor, and the door itself is not subject directly to the fire, but there's smoke that's coming down the hall. It wants to stop that smoke from spreading. Let's take a look at a specification. The references: Uniform Building Code, UL 10C, positive pressure fire door test. Anytime you see UL 10C, that means positive pressure. But now we also need to see, is it a category A or category B door? Here is an example of a fire rated door, category A, UL 10C, which means concealed intumescent in the edge of the wood door. Here's another example, and this one is a UL 10C positive pressure wood door, but this time the architect is specifying a category B, which means that you need a edge-mounted intumescent gasketing, whether it's applied to the door or applied to the frame. That will be part of the hardware set. And that will be like the PEMCO HSS 2000. That's a category G edge seal that is separate. It's not built into the door. And here's one more example. A category A for your 45-minute, 60-minute, and 90-minute doors, and these are wood doors. This is a wood door specification. Category B edge construction for 20-minute fire-rated doors, because those need the smoke and fire seal like the PEMCO S88. And that's not an intumescent. That's just a smoke seal that's applied to the frame. Now let's do a review. I'm going to put a question for you on there's a polling question. What type of seal is required for a 90-minute B-label hollow metal door? Your choices are A, category A, concealed intumescent, B, category B, frame applied like the PEMCO HSS 2000. Go ahead and answer the question on, you should have the poll question in front of you. C, seal is not required, or D, smoke seal like the PEMCO S88. Give you about 10 more seconds to answer the question on the polling. And don't worry, I can't see your answer and nobody else can see your answer. But the answer is C, the seal is not required. And why? If you remember, it does not apply to hollow metal doors because hollow metal doors will expand naturally when they're heated. And so therefore, we don't need an intumescent seal. And because of where they're located, unless they were specifically a 20-minute door, and the question wasn't about a 20-minute door. All right, the next one. What type of seal is required for a 20-minute rated wood door? I'll let the category come up and then you should have the polling question. Do you need A, smoke seal like the PEMCO S88? B, category A, concealed intumescent? C, seal is not required, or D, category B, frame applied like the PEMCO HSS 2000. What type of seal is required for a 20-minute rated wood door? Please go ahead and answer. 10 more seconds. And the answer is A, smoke seal like the Pemco S88. All 20-minute rated wood doors, whether they're going to be exit access doors, there'll be doors in fire partitions and smoke barriers, they will require smoke seal. And here is the slide, the category H, smoke and draft control, in compliance with NFPA 105. When you have a 20-minute door or an S label door, you need smoke and draft control. The next question: what type of seal is used for a 45-minute rated category A wood door? Here's your polling question. A, no seal is required. B, concealed intumescent in edge. C, frame applied intumescent like Pemco HSS 2000. Or D, smoke seal like the Pemco S88. Please go ahead and answer on your poll. And the answer is B, concealed intumescent in the edge. Category A, 45-minute wood doors, and here's the slide, they require the concealed intumescent, and it needs to be specified in your wood door specification that way. Couple more. What type of seal is required for a 90-minute rated category B wood door? A, no seal is required. B, concealed intumescent in the edge. C, smoke seal like the Pemco S88. Or D, the frame applied intumescent like Pemco HSS 2000. Give it 10 more seconds. And the answer is D, frame applied intumescent like the Pemco HSS 2000. And just to give you a reminder where that came from, category B doors require an additional edge sealing system. It does not apply to hollow metal doors, but it does apply to wood 45, 60, and 90-minute doors that have the added category G frame applied intumescent. 2 more. I know you guys are loving this part. What fire test requires doors to be tested under positive pressure? Is that A, UL10B, B, NFPA 252 with the pressure plane at the top of the door assembly, C, NFPA 105, or D, UL10C? Ten more seconds to answer. And the answer is D, UL10C. So when you see UL10C in a specification, that means the doors need to be tested under positive pressure. If you see NFPA 252, that alone is not enough information. The architect needs to say within the first 5 minutes or after the first 5 minutes, the pressure plane needs to be at 40 inches above the sill or less. And that indicates positive pressure also. So UL 10C or NFPA 252 with the extra language, the neutral pressure plane at 40 inches or less above the sill. And now we're down to the last question here. If a specification asks for category B wood 60-minute rated fire door, what category seal must be provided? Ten more seconds. And the answer is the category G. And to remind you where we got that from, if you have a category B wood fire door, then you need additional edge sealing system. That would be a category G intumescent. It could be applied to the door or the frame, but it means that it's not concealed in the door like a category A door would be. At this point, do you have any questions for me? I haven't seen any come up at this point. I'll wait for a few more minutes, but while we're waiting to see if anybody has any questions, I want to share with you, this is a tool that we developed a year ago. It's the Assabloi Egress calculator. It is free for everybody to use. You can find it at egresscalc.assabloi.com. You can use it on your desktop. It's mobile. You can use it on a tablet or smartphone. It's based on the International Building Code, and you can calculate the occupant load, egress width, quantity of exits, swing direction of doors, all with quick references to your hardware based on the IBC. You can download your input-output information in a PDF, as well as your code references so that you can look up things like delayed egress and access controlled egress and those kind of things. It's free to use if you're an Assabloi employee with your single sign-on. If you are a Assabloi customer, you can use your Connect to sign in and log in. And it's free for guests. You just need to put your email address in and a little bit of information, and it's free to use. There is a class, a virtual instructor-led training next week on this. So if it's something you're interested in, it's a 1-hour session on Thursday. You can go in and sign up for that class and get another hour of continuing education credit. I don't see any questions. So at this point, I want to say thank you so much for your attendance. If you have any questions in the future, my email address is here. Very happy to help you with any code questions that you may have. Also, we just started a new YouTube channel called Door Hardware Nerds. Check it out. I have Code Corner with Katie once a month, where I answer different code questions in less than 6 minutes, one question per session, and they're fun little videos that you can use as a reference over and over again. So thank you so much for attending, and hope to see you again at another session in the near future.